Hello everyone, hope you all are doing well. In this video, we'll discuss the third problem of Leetcode Weekly Contest 304. It's a medium level problem. The problem name is find closest node to given two nodes. So we are given a directed graph of n nodes numbered from 0 to n minus 1, where each node has at most one outgoing edge. Now this condition is very important. We'll see in the later part of the video why it is important. The graph is represented with a given zero index array edges of size n, indicating that there is a directed edge from node I to node edges of I. If there is no outgoing edge from I, then edges of I equals to minus 1. So you are also given two integers node 1 and node 2. Now return the index of the node that can be reached from both node 1 and node 2 such that the maximum distance between the so that the maximum between distance from node 1 to that node and from node 2 to that node is minimized. If there are multiple answers, return the node with the smallest index, and if no possible answer exists, return minus 1. Note that edges may contain cycles. Okay, so this is the example. Let's directly jump to the explanation, the diagrammatic explanation. Probably that will be easier, right? So it says that you are given a graph. If I'll just pick the first example itself, right? You are given a graph. So suppose this is 1, and we have an edge from 1 to 2. Then we also have an edge from 0 to 2, and then we have an edge from 2 to 3, right? So what it says is that now every node can have at most one outgoing edge. This is very important because if we would have had more than one edges growing or going out from one node, then it would have been an NP complete problem, right? So finding a solution in polynomial time would have been tough. So that is why this condition is very important, because it says that suppose you start traversing from here, you go somewhere this, you go here, you go here, and then when you come here you see, okay, somehow you find that, okay, I have a cycle. Now suppose again you start traversing from this node and somehow you reach this node, right? Somehow you reach this node which was already traversed. So you know that since this particular node has only one outgoing edge, right, so this node cannot form any other cycle. This is the only possible cycle that can be formed by this node, right? So because it has only one outgoing edge, right, to form another cycle, every at least one node needs any other edge, right? Like for example, if we would have had more than one outgoing edge, suppose this would have been another edge, and this node would have been connected to this one, right? But every node has at most one outgoing edge, and that cycle has already been traversed. So that is why this becomes a non-NP complete problem, right? This can be solved in polynomial time. So that is why I was saying that this condition is very important. I'll just remove this one. Now the problem says that what you need to do, select a node. Suppose I select 2. Select a node. So this is the graph that you are given, and you are also given a couple of more nodes. Suppose you are given node number 1 and node number 0. So 1 and 0 are given separately in the question. All you need to do, you need to find a node in this graph, so that when you calculate the distance from suppose 1 to that node, suppose 3 is that node, so suppose you calculate distance from 1 to 3, so it is 2, 1 and 2, right? And suppose now again you calculate the distance from 0 to 3, right, again it is 2, right? So the problem says that the maximum between the distance from node 1 to that node, so that means the maximum of these two, that is 2, is minimized, right? The maximum of these two, what is the maximum of these two distances from node 1 to this node? This is 2 comma 2, right? Because both the distances are 2, so maximum is 2, and obviously answer will be 2 in this case. However, if we take node number 2, right, so what is the distance from node number 1 to node number 2? It is 1. What is the distance from node number 0 to node number 2? It is again 1. What is the maximum of these two values? It is 1. So you can see 1 is the distance 1 is obviously less than distance 2. So in this case our answer will be node number 2, right? In this our answer will be node number 2. So we need to find one such node, and in suppose we have multiple such nodes, suppose we would have had one more node where the answer would have been 1, that means the maximum of the two distances would have been 1. So we would have returned the node having lesser value. In this is node number 2, and suppose we would have had up one node number 5 as well, so we would have returned 2 only. So this is the gist of the problem. Now let's, so once you understand the problem, it is very simple. All you need to do is apply DFS 2 times and we are good to go, right? And then we are good to go. Now let's see what we will do. So again, since we have only one outgoing edge, all we can do is that first apply DFS from this node, like the first node that you have been given, right? The first node. Now once you start traversing, so you start from this node. So you keep on traversing, the node. Suppose this is the node 1. So from this you see what is the outgoing edge. Suppose you move to node number 1, right? From this you move to node number 2. From this you need to node number 3, and so on, right? Now what we are doing, from this particular first node we are calculating the distance of each node in the graph. So the distance from n1 to 1 will be 1, the distance from n1 to n2 will be 2, the distance from n1 to n3 will be 3, and so on. So we take an array of size n, and this basically represents the distance of all the nodes from the given first node n1. So we have all the values, right? Similarly, we apply DFS from node 2 as well, and we get a second array which has the distance of all the nodes from n2, right? And then finally what we do, we have calculated the distances of all the nodes from this particular node. Now all we need to do is that traverse for all the nodes, like for example I equals to 0 to I less than n, right? These are all the possible values of nodes, and check that if like suppose obviously you will initialize all of them by -1, right? Because you'll initially, we know that the distances are -1. That means you can assume it to be that the distance has not been computed, or the current node is not reachable from the node 1 or node 2, right? So suppose -1 represents that. So all you need to do for every node, first check that whether these two values are computed or not, or these two values, both these values should be non-1. That means we have a path from node number 1 to this particular node, and from node number 2 to this particular node. So if a path exists, that means we have a non-zero distance or non-1 distance. Then let's move forward, and then what we'll do, we'll calculate the maximum of these two. That means suppose this is the ith node, so we calculate what is the distance of ith node from n1 and what is the distance of ith node from n2. What is the max of these values? Now if the max of these two values for the ith node is less than the maximum that we have seen till now, or the minimum distance that we have seen till now, we just update our answer, and then we are good to go. So this is the basic solution. Let's directly jump to the solution that I have written. So you can see on line number 12 the function starts, and then I have taken two arrays as explained in the problem, 15 and 16, distance 1 and distance 2, which represent the distance of each node from the given two nodes, node 1 and node 2, right? I apply DFS 2 times on line number 21 and 22. Let's go to the DFS function. So in DFS I am passing the edges array, I'm passing the node from which I need to calculate the distance. So for once I call node 1 and once I call node 2, and then I'm passing the array in which I need to keep the distances of all the other nodes from the given node, right? Let's come to line number 3. This is the DFS function. So initially the distance is 0. Now I can simply apply a loop, no need of recursion, because every node has just one outgoing edge. If it would have been multiple edges, I would have applied a traditional DFS recursive solution, but here that is not needed. So the start node is given, so edges of start node, if that is not equal to -1 and distance of edges of start node is not equal to -1, then move forward, right? What does these two conditions mean? The first condition says that if edges of start node is not equal to -1, that means you have an outgoing edge, right? You have an outgoing edge, otherwise it would have been -1. And the second condition says that if the distance of edges of start node is equals -1. Now this means that, so the graph can have cycles, right? Now if the distance of the node that I am going to traverse is not equal to -1, that means the distance has already been calculated, right? And that is the case of a cycle. I'll explain you that in the diagram as well. So these are the two conditions, right? These are the two conditions. And then what we do, let me just explain you that with the help of example so that we are not confused. So suppose this is the relation, right? This is the yeah, this is suppose we have a cycle, right? Yeah, this is suppose we have a cycle. So this is the starting one, suppose this is n1. So from n1 we move to node number 1, this is the distance 1. We move to node number 2, distance is 2. We move to node number 3, distance is sorry, node number 3, distance is 3. Now again from 3 when we move to 2, we see that, oh, the distance from node number 2 is already calculated, and that is equals to 1. So that means we are in we have encountered a cycle. So no need to update distance, because the minimum distance is not 4 but it is 1. So that is why I've added that these two conditions, right? The second one, distance of edges of start node equals -1. That means the distance has not been calculated. So that is the main motive of adding these two conditions. And on line number 6, what I've done distance of start node equals to distance plus plus, and start node is now updated to the node to which we are going from the current node, edges of start node, right? These are the two things. And finally, distance of start node equals to dist plus plus. So basic DFS we have done. So on line number 21, 22, I've called DFS 2 times, and then the basic comparison that we saw in the problem, answer is equals to -1. Minimum distance is obviously integer max value. On line number 26, you can see that if both the distances, we have valid values for both the distances, that means for the ith node, we can reach the ith node from both the node 1 and node 2, then only do the computation, else just continue. The current distance on line number 29 will be equals to max of distance 1 of I and distance 2 of I. Now if this distance is less than the distance that we have seen till now, answer is updated and min distance becomes equal to current distance. And finally we return the answer, right? So this is the main problem. So the main thing to observe here was that each node has at most one outgoing edge, and this problem was, I won't say this was an easy problem. We can learn a number of things from this one. So yeah, this was the main gist of the problem. Hope you learned something new. Please do support it by giving up a thumbs up. Do subscribe to the channel if you haven't done it till now. Also, in case you have any queries, do mention that in the comments. I'll try to resolve each one of them. Okay, thank you, take care, bye bye.